This is Mrs. Zappia with Lesson 6, Rotations of 180 Degrees. This is from Grade 8, Module 2. Student outcomes for this lesson. Students learn that a rotation of 180 degrees moves a point on the coordinate plane from point A, B to the opposite of A, the opposite of B. Students learn that a rotation of 180 degrees around a point not on the line produces a line parallel to the given line. The essential question for Lesson 6, what are three special features of 180-degree rotations? In example 1, this picture shows a 180-degree rotation around point O. Some things that I want you to notice about this rotation.
The first thing that I want you to notice is the distance from P to the origin. When you rotate your image 180 degrees about the origin, notice that the distance from the origin to P prime has been preserved so that PO is the same distance as OP prime. Then, if we rotate point Q about the origin, and here we have Q prime. Notice that segment QO is the same length as segment OQ prime. When you rotate an object, the length is preserved. Then, the other thing that I would like you to notice is the measure of the angle. Notice angle M, and this is the measure of angle M right here. When you rotate it about the figure, this whole angle will be preserved so that the new angle has the same exact measure. So we already knew that from our study about vertical angles, but rotating 180 degrees proves that the vertical angles are equal in measure.
So putting it together, what we've learned from this example here is that point P, the origin or the center of rotation, and P prime are collinear. They lie on the same line. And point Q, the center of rotation O, and Q prime are collinear. All 3 points lie on the same line. And then the other thing is rotation of 180 degrees proves that vertical angles are congruent. In example 2, the picture below shows what happens when there is a rotation of 180 degrees around center O, the origin of the coordinate plane. The first thing that I want to look at is point A compared to the origin. Point A to the origin has a length of 4. When you rotate it 180 degrees, it ends up at point A prime, and the length of the segment for A prime to the center of rotation is also 4 units. So we know that segment length is preserved. Then let's write the coordinates for those points. The coordinate for A is -4, 0. And on the 180-degree rotation on the x-axis, the x-coordinate will be 4, and the y-coordinate, since that point remains on the x-axis, is also 0. The next thing that I would like to look at is P and P prime. The distance between P and A is 3 units. Then, when you rotate point P and you get P prime, the distance between A prime and P prime is also 3 units. This again shows that distance is preserved when rotating. The coordinates for point P. The first coordinate is -4, +3. Then the coordinate for P prime. So our coordinates for P prime are +4, -3. So take a look at those coordinates. Notice that the y-coordinate went from a +3 to a -3. And notice the x-coordinate was -4, and now the rotated point is +4. The other thing that I want to point out here is the angle. So we have angle PAO is a 90-degree angle, And when this entire angle is rotated, it is still a 90-degree angle, showing that angle measures are also preserved when rotating. So summarizing what we've learned from this example, we see that when there is a rotation around the origin of 180 degrees, the point AB, the rotated point, will be the opposite of A and the opposite of B, as shown here, where A is negative and then the rotated point is the opposite, which is positive, and then point B, which was positive, became negative. And this is an important concept for rotating 180 degrees. For exercise 1, use your transparency. Rotate the plane 180 degrees about the origin. Let this rotation, O, what are the coordinates of the rotation to -4? So the directions for this, you can copy them if you would like to, are to draw a line from 2, -4 through the origin and extend it. The rotated point will then be on that line. Then trace your center of rotation, the line, and the point. On the reverse side of the tracing paper, trace the line of rotation and the point. Then return it to its original position. Then we'll rotate it 180 degrees till the point is on the drawn line. We'll label the image of the point and the coordinates. Then we'll write the statement.
So I have my pencil tip on the origin and I rotate it 180 degrees. I know it's 180 degrees when the point -66 is back on the line. There we go. Then darken and label your line. And that will be L prime. You may need to darken that line a bit.
We've rotated our point, and our statement is the rotation around the origin of point 2, -4 results in a new point of -2, +4. Exercise 2. Let rotation O be the rotation of the plane by 180 degrees about the origin. Without using your transparency, find the rotation of -3, +5. So in this problem, we know a couple of things. We know that the distance is preserved. So the distance from the point to the origin will be preserved. And when we put our new point on it over here, it will be the same distance as the original point is from the origin. The other thing that we know is that the distance to the x-axis will also be preserved, and the distance to the y-axis will also be preserved. So the distance on the x-axis is 3, and it will remain 3. The distance along the y-axis is 5, and it will remain 5. So this distance is also the same as the original distance. So we can use that information to plot our new point. So the rotation, let's write our statement. The rotation about the origin for the point -3, 5 is the new point, +3, -5. Number 3, let rotation O be the rotation of 180 degrees about the origin. Let L be the line passing through -6, 6, parallel to the x-axis. Find the rotation about the origin of line L. Use your transparency if needed. What I want you to do on this problem is to take your tracing paper and place it over the image, and then I would like you to draw this line right here through the point and the origin and extend it. And that way we'll have our line of rotation when we move our transparency paper.
So I have my pencil tip on the origin and I rotate it 180 degrees. I know it's 180 degrees when the point -6,6 is back on the line. There we go. Then darken and label your line. And that will be L prime. You may need to darken that line a bit.
Let's write our statement for the rotation. We have a rotation around the origin of line L, and we'll call that L prime. Notice the coordinate. The coordinate of the original point was -6, +6, and the coordinate on the rotated line is +6, -6. Number 4. Let rotation O be the rotation of 180 degrees around the origin. Let L be the line passing through 7, 0, parallel to the y-axis. Find the rotation L. Use your transparency if needed. So here we have the point 7, 0, and we want to rotate it about the origin 180 degrees. You will need a line passing through the origin to any point on L. So I'm just going to pick this point right here. And let's see, that's 7, 3. And then draw a line through the origin and through that point. And extend it. That will be our line that we are rotating it through. Then take your transparency and we'll rotate the line.
I've got my pencil tip on my tracing paper. I'm going to rotate it 180 degrees. And it's back on the line, and then just going to straighten it out there. Darken my line. Notice my point is on the line of rotation. Remove it, and you may need to darken that line. And this is the rotation. We'll call that line L prime. And then this point, which was 7, 3, the rotated point is -7, -3. Again, notice that the coordinate, the A coordinate is the opposite of what it was, and then the B coordinate was +3, now it's -3. Then the B coordinate is the opposite of what it was.
And we'll write our statement of rotation. We have a rotation around the origin of line L, and that gives us L prime. Number 5. Let rotation O be the rotation of 180 degrees around the origin. Let L be the line passing through 0, 2, parallel to the x-axis. Is L parallel to the rotation of L around the origin? So darken your line, and then what we'll want to do is draw a point on the line somewhere, and let's take a point over here. Let's use 0, 1, 2, 3, 4, 5, 6, 2. Our point is 6, 2. So we pick any point on line L and draw a line through that point and through the origin. And that will be our line of rotation. Then we'll rotate the point and the line. So trace the line and trace the line of rotation, then we'll rotate it.
I've traced my figure and I'm ready to rotate it. Place the pencil tip on the origin, rotate it 180 degrees, and trace your line and label it.
Let's write our statement of rotation, and we are going to do rotation around the origin of line L, and that gives us L prime. I also want to write out the coordinates. The rotation around the origin for the coordinates 6, 2. Result in the new coordinates -6, -2. 5. Is L parallel to the rotation? So the rotation around the origin of L is parallel to L. Number 6. Let the rotation O be the rotation of 180 degrees around the origin. Let L be the line passing through -4, 0. Notice that this is a typo. It should say -4. And it's parallel to the y-axis, and that should only have one y. Is L parallel to the rotation around the origin of L? So in order to do this rotation, take a point and let's pick another point. Oh, let's do this one up here. So we have -4, 1, 2, 3, 4, 5. This point is -4, +5. Then draw a line through that point, through the origin, and then just extend it. And then trace that line, the original line L, and the line that we've drawn. Then we'll rotate our point. Is L parallel to the rotation of L? So we look at those lines, those two red lines, and we see they do not intersect and they never will intersect. They are parallel. Let's write our statement. The rotation around the origin of L is parallel to L. Number 7. Let rotation O be the rotation of 180 degrees around the origin. Let L be the line passing through 0, -1, parallel to the x-axis. Is L parallel to the rotation of L about the origin? So pick a point on the line and draw a line through the origin to that point. So let's try point -3, -1. Then draw a line through that point and continue it past the origin. Trace those lines onto your paper and then rotate your image 180 degrees.
Place your pencil tip on the origin and rotate your figure 180 degrees. Then darken your image and label it. And we have the point 3, 1.
Is L parallel to the rotation of L? So here is line L, and here is the rotation of line L, and they are parallel. If you extend both of them in either direction, they will never intersect. So let's write out our statement. The rotation around the origin of line L is parallel to L. Number 8. Let rotation O be the rotation 180 degrees about the origin. Is L parallel to the rotation of L? Use your transparency if needed. So one of the things that I want you to notice so far is that when we rotated 180 degrees, a horizontal line, we ended up with parallel line. And in the previous example, we rotated horizontal line, and we ended up with parallel lines. So in this example, we are looking at a line that's a bit on a diagonal, and we're also going to rotate it about the origin, and we're going to rotate it 180 degrees. So do you think that this will result in a parallel lines as well? Pick a point on the line, and then we will draw that point. So let's pick a point on the line. How about this one right here? and that point is 3, -2. Then draw a line through that point through the origin and extend it. Then place your tracing paper over this figure and trace it.
Place your pencil tip on the origin. Rotate your paper 180 degrees until the point is back on the line. And then sketch your line and label it.
Let's take a look at those points. Here we have the point 3, -2, and here we have the point -3, +2. So we know that the distance was preserved. Let's take a look at one more point. Let's take a look at this point here. This would be point 2, 2, 4, 6, 7, 2, -7. So let's go over 2 and up 7, and notice that that distance is preserved as well. So we'll write out our statement. This is the rotation about the origin of line L. Number 9. Let rotation O be the rotation of 180 degrees about the origin. Is L parallel to the rotation of L? Use your transparency if needed. So on this figure, there is no grid. What we want to do is pick a line or pick a point on the line, any point, and then you need to draw a line going through that point to the origin and then extend it. Then put your tracing paper over your diagram and trace it. And then we'll rotate it about the origin, which is right there.
I've traced my lines. Now I'm going to place my pencil tip on the point O that we are rotating it around, and making sure that it's lined up carefully. Then rotate it 180 degrees and sketch your rotated line.
And the question is L parallel? So let's write our statement. We have the rotation around the origin of line L is parallel to line L. We're going to skip example 3 for now, and let's go down to our lesson summary. A rotation of 180 degrees around O is a rigid motion, so that P is any point in the plane. P, O, and the rotation P are collinear. That is to say that P, the original point, and O, the point of rotation, and P prime, the rotated point, are collinear. They lie on the same line. Given a 180-degree rotation about the origin in the coordinate system and a point P with coordinates A, B, is generally said that the rotation around the origin of point P is the point with the coordinates the opposite of A and the opposite of B. Let O be a point not lying on a given line, then a 180-degree rotation around O maps L to a line parallel to L.